Hello friends, welcome to another tutorial in network analysis and synthesis. We are currently pursuing graph theory, and in the last tutorial we did incidence matrix. After having formed incidence matrix for a graph, the next step is to be aware of the Twig matrix and link matrix. Please understand, out of this graph we need to make several trees, or we can make several trees, and for each tree there are going to be twigs and links. Now if you do not have the understanding of a tree, the branches of the tree which is known as twigs, and the rest of the leftover branches which are known as links, please refer to the previous videos where we discuss formation of trees out of graphs. But in this video we'll straight away find the twig matrix and link matrix for a tree. Please understand there are many possibilities of generating a tree out of a graph. For example, this graph could result in the formation of a tree which could look something like this. Basically, a tree is something that would have branches that would connect all the nodes just once, that would touch all the nodes just once, and no redundant paths are going to be there. So these solid lines are known as twigs of a tree. So this tree is covering all the nodes. The nodes are being connected, no closed loops are formed. And these leftover branches, which when connected will form closed loops, are known as the links. Alright, so the blue lines, they represent the twigs. So I can say twigs are 2, 3 and 4, and links are 1, 5 and 6. Now when we make the incidence matrix, this incidence matrix of this graph has already been made here, and it's been populated depending upon which branch is moving out of the node, which branch is coming into the node. We have assigned ones or minus ones, and which branch is not incident at the node at all, we have assigned 0. So again, if you do not have complete understanding of incidence matrix, refer to my previous video. But this is the incidence matrix of the entire graph, where these are the branches. So 6 branches and 4 nodes. Now if a tree is selected from this graph, then the first n minus 1 columns will correspond to twig. So this is the first point that we need to remember, that for a graph of 4 nodes there are going to be n minus 1 twigs. This formula is already known to us, where n is the number of nodes and minus 1 is the number of twigs. So the first n minus 1 columns will correspond to the twig. It will generate a matrix where we'll separate out the twig matrix and the link matrix. So the first n minus 1 column will correspond to twigs, and the last b minus n minus 1 will correspond to the links. So let us see how that is achieved. So we can simply segregate the twigs, which are 2, 3, 4, and I'm gonna separate out the links columns 1, 5 and 6. Alright, now we simply need to copy the columns 1, minus 1, 0, 0, 0, 1, 0, minus 1, and 4 is 0, minus 1, 1, and 0. For 1 it is 1, 0, 0, minus 1, 5 is 0, 0, 1, and 6 is 1, 0, minus 1, and 0. Now please understand this new matrix is subdivided into two submatrix, AT and AL. Now AT is the Twig matrix. Now one way of doing is to simply segregate the columns for twigs and rows and find out twig matrix and link matrix. The other way is to reduce this matrix and form the reduced twig and link matrix. If we eliminate the node 3, the reduced matrix will become so this will be the reduced matrix. Now we have eliminated this row from the matrix to obtain the reduced matrix, and if you wish to draw the reduced twig and link matrix, you can simply segregate. This is, by the way, 1, 2, 3, 4, 5 and 6. If you reduce, this will become a matrix of a 3 by 3 formation for both twig and link matrix. So it will become so this will be the reduced twig matrix and this will be the reduced link matrix. But the main point here is to identify while drawing a tree which all branches are designated as twigs and which all branches are left as links, because you could try out a similar question using this tree where we could have, this is also a tree, by the way. So now branch 1, 2 and 5 are the twigs and 6, 3 and 4 are links. So you'll see that the link and twig matrix will change. And another property of the twig matrix is that the determinant of the twig matrix is non-singular. So you could remember that from the point of view of multiple choice questions, but it is pretty easy for a particular tree. Simply identify which branches are twigs and which branches are links. So once you do that, you simply need to segregate them. You need to separate the first n-1 columns as twigs, and the last b minus n minus 1 as links, and the resultant matrix is the twig matrix and link matrix. And I hope this quick tutorial was of help. We'll continue with the series, and I'll see you in the next video. Take care. Bye.